Hello everyone, welcome back to the channel. So in this video, I will be explaining the problem C of the last educational Codeforces round, that is round 162, and the problem name is find B. So let's start by understanding the problem statement. After that, we will talk about the approach part. So they have been given an array A of length M, and that array is considered good if there exists another array B of same length and the following three conditions hold. First condition is the summation of the first array and the second array should be same. Means the sum of the elements of the first array should be equals to the sum of the elements of the second array. Second thing is none of the element of the first array should be equals to the element of second array. And third condition is the element of the second array should be each element of the second array should be greater than 0. These are the three conditions that should be satisfied, and we have to report that whether any another array B exists or not for the given array A. And they are not asking for the whole array, they are given some queries, and we have to report for given sub array. Means they have been given some ranges like 1 to 5, 4 to 4, and we have to report the answer for 1 to 5. Means if I talk about 1 to 5, then it will be considered as the whole array, and if I consider as 1 to 3, then this sub array should be considered 1 to 1, and we have to report that 1 to 1 is a sub array between 1 to 3. Okay, and we have to tell that whether any another array of same length exists or not, such that the sum of elements of this array should be equal to the sum of elements of this array, and none of the element of this array is equals to the element of this array at respective indices, obviously. Okay, so this is the problem, and now let's talk about how we can solve this. I will take a simple test case and I will try to extend that in order to reach the complete solution. Okay, so let me take the first any sample test case. For example, 3, 4, 5. This is the case that is given to me. This is the array or the range that has been given to me. The elements of that particular range are 3, 4 and 5, and I want to find a array of length 3 such that sum of I'm calling this array B and this array as A. So I'm saying that the summation of array B should be equal to the summation of array A, and that is 12. Okay, means all the elements of array B should sum up to 12. Don't you think so? A simple observation here that if I place 1 here and 1 here, then obviously this is not going to become equal to the respective elements. I'm considering for now that no element is equals to 1 in the first array. Means this is my case 1, that none of the element is equals to 1. And why so? I will come to that later. None of the element is equals to 1. Okay, all the elements are greater than 1. So in that condition, I will put n minus 1 times 1, and I'm sure that none of the element is equals to 1. Then these elements are not going to become equal to their respective elements in A. Okay, and at the end, what I have to place here is obviously something will be getting added to this, because these all are greater than 1. Then some part of these will be getting added to 5. For example, I have taken 1 from here, so 2 will be extracted from here and 3 will be extracted from here. So total in 5 will be added to here. So this element will become 10. So I have proved also that this is also not gonna equal to the last element of the array. Why so? Because I'm taking something from this, and I'm adding something to this. Okay, so this will gonna increase in any case. One thing is for sure, that if none of the element in the range is not equal to 1, then my answer is always yes. Okay, I hope this thing is clear. Now let's move on to case 2. Case 2, when sum of the elements are equals to 1. So for example, 1, 1, 2 and 3. This is the case. Now what I have to do? I know that I cannot put 1 on these two indices. Okay, I have to place something else on these two indices except 1. So what I will do is I will place 1 on these indices which are not equals to 1. What I will do is I will count the number of ones, and after that I will proceed to my solution. So I can place 1 on the indices which are not equal to 1. And what is the remaining thing that I'm getting? Remaining thing that I'm getting is 1 from here, because I have kept 1 here. So 1 will be extracted from here, and 2 will be extracted from here. And why I'm doing so? Because I want to make the sum of these two arrays equal. So in total I am having summation of 3. Okay, 3, and I know that I have to place a number greater than 1 here. Okay, so now I am having 1 plus 2, means I am having 3 extras, and I can place 3 extras on these two indices. Okay, so if I place 1 here, so it will become 1 plus 1 2, and if I place remaining one is 2, so if I place 2 here, then this will become 2 plus 1 3. So you can see that the summation is still equal, and the elements are also not equal, and all the elements are greater than or equals to 1 in array B. So condition is satisfied. So now you can see the intuition that why I'm going to store the number of ones and I'm focusing on the sum. Okay, so what two things I need: the number of ones in the given range and the summation of all the elements which are extra. I'm getting extra by putting 1 on the elements which are not equals to 1. Now let's suppose the case is something like this: 1 1 1 1 and 2 3. Okay, I know that I cannot put 1 on these 4 indices because this will be violating our condition that none of the elements should be equals to the element of array A. So if I place 1 on these 4 indices, any one of them, then that will violate our condition. But I know that I can place 1 on these indices, and I'm placing 1 so that I can extract maximum extras in order to place on these indices. So what are the extras that I'm getting? 1 from here and 2 from here. So in a total I have 3 extra elements which I can add on these 4 indices. Okay, but the thing is I have only 3 elements. Okay, I have only 3 elements and I have 4 indices in where I have to add at least 1, because these numbers cannot be equals to 1. So I have to at least add 1 to each element in order to make 2 2 2, so that they cannot become equal to the element in the array on their respective indices. So I know that I will need at least plus 1 here, plus 1 here, plus 1 here, and plus 1 here. In total, I need 4 extras in order to make 2 2 2 2, so that they cannot be equal to their respective elements in A, and also the value is minimum possible so that I can utilize the extras in a better manner. So I will need 4 extras here, minimum 4. Maximum it could be up to any number, but minimum 4 is required here. But I am having only 3 extras. In this case, I will say that no, my answer is not gonna possible. I cannot make a valid B array. I hope this is making sense to everyone, and intuition is clear that how we are approaching to the solution for this problem. Okay. Now the thing is how to code this up. Simple thing is, let's suppose 1 1 1 1 2 and 3. So you can make prefix array or segment tree, anything you can use. Make 2 prefixes. One prefix will store the count of ones till that index. For example, let's suppose P1 is storing the number of ones till ith index. So P1 will be generated as 1 2 3 3 3 and 3. So this is denoting that till this index, what are the number of ones that are appearing, okay, from 0 to ith point. And we are generating P1 so that we can find the number of 1 in the given range in order of 1 time. Okay, and after that create the simple P2, which is prefix sum, or you can also create a segment tree in order to get the summation of the elements, means the extras, these extras. Before creating P2, subtract 1 from each element. Why so? Because these all the ones which are, because the elements which are 1 will become 0 0 0 and 0, and these will become 1 and 2, because we are placing 1 on the indices which are not equal to 1. And after placing 1, these are the remaining extras which I'm getting, and on these extras just create the prefix array so that you can get the prefix sum of the range, that how many extras I can get from this range. Okay, so for example, the above array is 1 0 0 0 after placing 1s 2 and 3. So this is denoting that P2 will be created as 0 0 0 0 2, and this is 1, actually 1, and this is 2. So it will be 1 and here it is 3. So it is denoting that if I consider complete array, then I will be having 3 extras, because I will what I will do is P2 of R minus P2 of L minus 1, that will give me the extras in this given range, and number of ones will be given by P1. So the number of ones will be given by P1, and that is 4. Number of ones is 4, and extras will be given by P2 of R minus P2 of L, that is 3. And if ones is greater than the number of extras that I'm having, then answer is going to be no, otherwise answer is going to be yes. And beforehand you have to check one more condition, that whether number of ones are zero or not, means if any one is present in my given range or not. If no one is present, means no one is one, none of the element is equals to 1, then the answer is always going to be yes, as I have talked earlier. Okay, here how we can do that, we will place 1 1 1 and remaining element at the end, and something is getting added to this, so this is also not gonna equal to the respective index element of the index in array A. So this is how we can proceed to solve this problem, and this was not too much hard but quite intuitive to solve. Okay, I will also make a video on problem E that was quite good based on DSU problem. This is problem E. Problem E was quite interesting. I found that problem interesting because I generally find graph problems very easier to solve. Before that, let me show you the code for the problem C. I have created the segment tree. Don't confuse that what is this. Okay, this is just segment tree to find the prefix sum. You can also make the prefix sum. And now here is the main code. N and Q is given, array is given, and I have created the prefix 1. This is denoting the number of ones in a given range. Okay, and I have created a segment tree to find the prefix sum of a given range. This is I have done just for the practice. You can also create a prefix array for this. And after that, I have created the prefix array, and I have found the sum of a given range by segment tree. After this, sum is extras basically, and what I am storing in segment tree is where it is present. Array of I minus 1 is being stored. Okay, array of I minus 1. So I have explained you that before creating the P2 array, prefix 2 array, subtract each element by 1 in the array and just create the prefix array in the general manner that you create. This is what I have done in the segment tree. I am storing the array of I minus 1, and this sum is denoting the extras in the given range from left to right, and ones is the prefix of I minus prefix of left, because I am storing prefix in a manner I plus 1. Okay, means for propagation type. So I have found the sum of the extra elements and the ones counts in the and the number of ones in the given range, and if the ones are less than equal to sum, then answer is going to be yes, otherwise answer is going to be no, because extras should be always be greater than equals to the number of ones in a given range, as I have explained. So yeah, this is all about this problem, guys, and just go and solve this. I will make a video on problem A that was good for solving a tree problem.